In this lesson, we're going to talk about streams in Node. Streams are a pattern for handling input and output. If you're familiar with the command line, you might know that a lot of command line utilities use streams to pass data from one tool to the other. Maybe you've seen or used a string of command line utilities where you use the pipe symbol between them, and where you pipe output from one command as input to the next command, and then the output from that command maybe as input to the next command, until you finally finish manipulating the data and it's maybe printed out to the screen or into a file or something. Well, we can do something similar to that in Node with streams. In this lesson, we'll look at how you can use streams in Node. However, if you are new to streams, this method of input and output may seem a little bit strange to you, and it may not be immediately obvious where it would be useful. So I'll have some links underneath this lesson where you can learn more about streams and see how they may be used in a more practical way. You can get the stream module by doing require stream, and then there are two types of streams. There are readable streams and there are writable streams. Readable streams are streams that output data that you can read, and writable streams are streams that take data as an input and you can write to them. I've called this file fib.js, which is short for Fibonacci, and so we're going to create a stream that outputs a sequence of Fibonacci numbers. Now, if you're familiar with the Fibonacci sequence, you know that you can start with two numbers. We're going to start with A and B, which are 0 and 1, and then you get subsequent numbers by adding the two previous numbers. So we start with 0 and 1, and then we add those two numbers to get 1, and then we add 1 and 1 to get 2, and then we add 1 and 2 to get 3, and then we add 2 and 3 to get 5, and 3 and 5 to get 8, and 8 and 5 to get 13, and this can just continue infinitely. And this is the Fibonacci sequence. So let's go ahead and create a readable stream. So I'll just call this rs for readable stream, and I'll say new stream.readable. And then what we have to do to make this stream readable is give it an underscore read function. And this function is the function that will determine what can be read from this stream. And the way we do this very simply is inside this function, we can use this .push to push values out of this stream, and those are the values that can be read from the stream. And then when the stream ends, we do this .push and we pass in null, and that will be the final value in the stream. So let's do it like this. Let's say if b is less than or equal to 144, which I happen to know is a Fibonacci number, then we will continue, because we could make this an infinite stream, but we'll use this if statement to make it a non-infinite stream. So if b is greater than 144 at any point, then we'll do this .push and we'll push null to end the stream. Otherwise, what we're going to do is calculate the next Fibonacci number and push it out of the stream. But one of the benefits of streams is that you don't have to worry about the timing of objects being pushed out. You can just wait as long as you need to, and whenever you have that next object or the next value ready to be sent out, you push it out, and whatever is reading from this stream will be there to catch it and read it. So in this case, to kind of show that we can have some delay, we will use a set timeout. And we'll only wait about 100 milliseconds, but you'll be able to see that delay when we look at the output. So in here, let's create C, which will be our next number in the sequence, and we do that by adding the two previous numbers together. So that's A and B. And then we want to update A and B to the new previous numbers. So we'll set A equal to B and B equal to C. And then finally, we can do rs.push. But I can't just push out C because C is a number, and streams expect their values to be strings by default. We can switch it to be numbers or any kind of object that JavaScript has, but we'll stick with the default, and I'll just prepend a empty string so that this number will be a string. So this is really all we need to do to create a readable stream. It's really that simple. All we do is create a new instance of a readable stream, and then we create a read function that does whatever data creation or calculation we need and pushes out the values of the stream one at a time. And then when this is done, we push the null value so that the stream that's reading from this readable stream knows that that is the end. And now what we can do is pipe our readable stream into a writable stream. And so that writable stream will write out whatever it's reading from our stream. Now, the easiest writable stream that we have is the standard output, right? Just print it out to our console. So I can do rs, which is our readable stream, .pipe, and I will pipe this content into process.stdout, standard out. This is really all we need to do to output whatever is being read from a readable stream to process.standardout. And we also have to do process.standardout.on error process.exit. And the reason we have to do this is because when the stream ends, process.standardout will actually throw an error. And so we just catch that error here and we exit cleanly. Now I should be able to run fib.js and we can get the first 10 or so Fibonacci numbers. So I'll just do node fib, and you can see that we have nothing printed out. And that's actually a small mistake on our part. I said b is greater than or equal to 144. It should be less than or equal to 144. And actually, let's just say less than 144. Okay, so now if I run it, you can see one by one, each of these numbers are printed out. And we could actually, let's add to the end of what we're pushing out a new line, just to make it a little bit easier to see. And let's run that again. And now you can see they're printed out 1, 2, 3, 5, 8, 13, all the way up to 144. And notice how there was a slight pause between each of them. And that is because of this set timeout that we're using. I could actually cancel the set timeout here if I just comment out those two lines. And if I run this file again, you can see it's pretty much printed out instantaneously. I just put the set timeout in there to show you that timing is not an issue when it comes to a readable stream. A writable stream, that is reading from the readable stream, can wait for values to become available and will read them when they do become available. That's part of the beauty of streams. Now, in this case, we're piping our readable stream to a default writable stream that is previously created for us, the standard out. However, instead of doing that, let's create our own writable stream. First, let's export this stream. So I'll say module.exports equals rs. And now let's create a new file, and I'll just call this out.js. So I'll get our stream right here. And actually, we don't need the whole stream object. We just need the writable class. Actually, we just need an instance of writable. So I'll create our writable stream ws by requiring stream and then just calling. And I don't think we need new, but I'll just put new in there anyway. Let me put a parentheses around this just to make sure everything is called in the right order. So we have our writable stream. Let's also get our fib generator. And so we'll say fib equals require the local fib file. And now we need to give our writable stream an _.write function. And this write function takes 3 parameters. It takes the next chunk of data, it takes the encoding for that data, and it takes the next function. And the next function, and the chunk, of course, is the chunk of data incoming from the writable stream. And the encoding is however that is encoded. And next is what we call when we're ready to get the next value from the readable stream. And if you think about it, this means that not only do we not need to worry about the timing coming out from the readable stream, but we also don't have to worry about the timing as our data is coming in to the writable stream. We can have both being delayed for some reason, and everything will still work out because we choose exactly when we want to either send the next chunk from the readable stream or get the next chunk from the writable stream. So what I can do in here is, let's just do console.log chunk.toString. Chunk is actually going to be a buffer, so I'm just going to have to convert it to a string, which is very simple. One thing I do want to do, let's remove here in our readable stream, let's remove this new line that we're adding because console.log will do it for us. And then what we can do here is just call next. And then, so we create our writable stream here, and then down at the bottom here, let's do fib.pipe, and we're going to pipe our readable stream into our new writable stream. It's that simple. Let me go node on our out.js file, and you can see that we have the very same content printed out. Now, I do want to point out here, first of all, in this readable stream, we are only printing out Fibonacci numbers until a certain value. Let's change that. So let's just get rid of this whole timeout thing and the whole else statement. And all we're going to do in readable stream here is calculate the next Fibonacci number and push it into the stream. This way, we will be calculating Fibonacci numbers basically infinitely. So right now, if I come back to the console and I rerun that file, you can see that very quickly we hit infinity. That was pretty much instantly. And so that is a lot of numbers being calculated. But what we can do to kind of throttle that is from the out.js file, we can have our set timeout in here. So I could say set timeout, and we'll set timeout on calling the next function, and we'll call it every 100 milliseconds. And so now, if I run that file again, we still have the same calculations being done, but notice they do happen much more slowly because we are choosing how fast we want to read those numbers. And very soon this is going to hit infinity. And then to quit this, I'll just hit Command C. But you can see how we can control the output from our readable stream just by delaying our calling of next. We could, of course, even do a count here. So I say var count equals 0, and then I can say if count plus plus is less than 10, then we will call next. And this way, if I run node.out again, we'll just get the first 10 values, and then the writable stream will just stop reading. So this is a basic example of how streams work in Node. If this is your first introduction to streams, you may not understand exactly where they will be useful, but I'll add a link to a really helpful tutorial under this lesson on how you can actually solve programming problems using streams. And I think that will open your eyes a little bit more to how useful streams can be.